Hello everybody, Mr. Perry here, trying something new. We'll see how well it goes and if it shows up well on the screen here once I get done recording this. But anyhow, for this part of the unit, we're talking about piecewise functions still, and we're going to talk specifically about how you would get domain and range. Now, what you've seen in the past is just picking out certain points, and the domain and the range were just numbers. Here, since we're dealing with piecewise functions and we're dealing with a bunch of different types of lines or segments or whatever it is that comes up on the piecewise function, the different parts, we're going to have intervals that come up with piecewise functions and how we figure out what the domain and the range is for that. So I'm going to take a look here at this picture, and I have domain and range. That's what it is that I want to figure out. So in this picture, we know two things. We know that domain is our x values and range is our y values. And what I want to make sure that I know from that is that I'm going to be checking out those different axes when I talk about that. Or in this case, since it's plural, axes. So domain is the x values. I'm going to check out the x-axis. And I have a ruler here. If you have a ruler at home, it might be a good idea to use this. There's some sort of tool maybe to help you understand that we're not just restricted to the picture, right? We keep on going off of the chart. This would go forever that way, forever this way to the left. And I'm looking at the x-axis here and what's happening with this picture. What amount of area, what points would I have for the domain, x values. So a lot of stuff is happening in the middle of this picture, but I kind of want to look at the edges. So for instance, if I start, and we kind of read left to right here, if I'm all the way out here at this ruler, technically this is, from geometry, this kind of looks like a ray. And this arrow is going out here forever and ever and ever and ever, which means that if I kept on extending this ruler out, it would go forever and ever and ever to follow that line. So we're going further and further out to the left here, and it's never going to stop going to the left. So we're going all the way out here to, we would call this idea negative infinity. On the right side, it's a similar concept. It's not a straight line, but if you take a look over here, we're going forever and ever to the right. And this ray right here would continue to extend off of the chart, past my ruler, going on forever and ever and ever. So when it comes to this x value over here, I'm going to put this down here, hopefully that's okay. This going off to the right side is going on for a positive infinity. So the way that we write that interval for what we have going on here, the restrictions and giving us the interval in which this piecewise function is going on, is we're going to take into account both the negative infinity and the positive infinity, and the fact that we have points in between those also. So when I'm going to come over here to the domain, how I write that out is that it's going to be negative infinity, and we want to cover everything in between. So it's negative infinity is less than, x is less than positive infinity. When we have our arrows pointing off to the left, what that means is that we're covering everything in between negative infinity and positive infinity there. For the range, it's a little bit different. We have our y values for range, as we know. So we're going to check out the y-axis. We're going to kind of use that as a guideline here. And again, if I look at the y-axis, we'll go up to down here so that we can kind of understand what's going on. And if I look at the up part of this here, all the way up as high as you can possibly go, that would be positive infinity. Here, we have nothing really going on until we get to here. Now, this arrow, even though it's stopping right here, we know would extend forever and ever and ever upwards. It extends forever to the right, but it's also extending forever upwards. So when it comes to our y values up here, we're going to go on and on forever. So for our y values, we would eventually go to positive infinity. When it goes to my lower half of this chart, and I'm kind of working my way down here. All right, we have a ray coming over here, and then we have this dot. I'm going to pull away the ruler for a second there's nothing really going on below this dot. There's nothing extending here. This line's going to be flat forever. This line is only going upwards and to the right. There's nothing below that dot. That dot right there is the point 1, 1. And we want to focus here specifically on the y value since we're looking for a range. The dot is also open. So we know, since we're going to go all the way to positive infinity, and we're stopping at the number 1 for the letter y and for our range, that the way we're going to write that out in interval notation is I want to make sure that I know that we have available to us here for the range every single point above y being 1. So we write it out as y is greater than 1. We're going to write that out as y is greater than 1 because the dot's open. It's not included. If it was colored in, we'd have a little dash underneath this arrow. But since it's open, that means that we're just going to leave the arrow being y is greater than 1. So again, for this, we're looking for our domain and our range for this piecewise functions. Our domain, we know that for our x values, since we have things extending to the left all the way and extending to the right all the way, we're going to have negative infinity is less than x is less than positive infinity. For our range, we're going to have y is greater than 1 because there's nothing going on below the y value of 1, and that dot's open.